Welcome back to CCNA 2. We're going to talk about HSRP in this video. We're going to go into detail. We're going to tell you all the nitty-gritty details about HSRP, how to configure it, how exactly it works. So let's get started here. So we're going to pick active and standby routers for our network. By default, the router with the highest IPv4 address is elected the active router. Now remember, most layer 2 technologies are going to use the lowest MAC address, the lowest numbers, and most layer 3 technologies are going to use the highest numbers, like the highest IP address. So we're going to prefer the highest IP address to be the active router. It's always better to control how your network will operate under normal conditions rather than leaving it to chance and not really paying attention. So we really want to be specific in how our network is going to work, and we need to know how it's going to operate when things fail. So HSRP, can be used to determine the active router. So we can set the highest HSRP priority, right? Remember, highest is better in, or higher, I should say, is better in HSRP. So by default, the priority is 100. We can go from 0 to 255. So some people may go for 101. I usually prefer to go to where I have kind of room on both sides. So I would potentially pick somewhere between 150 and 200 for my primary router. And I would probably leave a secondary at maybe 102 or 105 or something in that range, so that if I added a third router down the road, I wouldn't have to worry about it taking over as a primary in the case of the primary failing. I wouldn't leave that choice up to chance. So depending on how many routers I have in the HSRP group, or in the real world, I would be using VARP or GLBP. But in that group, I would want to make sure I have my priorities set correctly so that I'm not confused and I understand which one is going to take priority depending on which ones are online. So if the priorities are equal, we're going to use the highest IPv4 address. Of course, we just said that. And by default, they're all 100, so they would be equal. So you'll see this has a higher priority over here, so this guy would become the active router, and he would take over our virtual IP address. So even after a router becomes the active router, it will remain active, even if another router comes online with a higher priority. So by default, HSRP is not going to re-elect the active router unless the active router goes down. This is good because you could potentially have an outage if you had another router come online with a better priority, and it would take over, and then that router would go offline, and then it would come back online and take over, and then go offline, and then come online and take over. And there's been situations where that's happened. This technology, along with others, have these safeguards in place so that if a situation like that happens, which could, to where you have kind of a boot loop or some other kind of issue that's causing the switch to reboot, that you're not going to constantly re-elect our active router. So if we want to force a new HSRP election, we can set preemption. So that's an option if we want that to happen. Now, usually we're also going to do some other things along with preemption so that we make sure that situation doesn't happen, such as wait 60 seconds before we actually preempt and force an election. Preemption will force a new election, literally called a coup. So if you're not familiar with what a coup is the idea of overthrowing a government, usually violently. Think of, trying to think of a good example. Think of America. Think of America's independence as a coup against England. You could say that. Anyway, so it's kind of humorous. I find it humorous. But anyway, we'll continue on. So if preemption is disabled, then whoever is the active router will stay the active router until it goes offline. So the HSRP states and times, we're going to have the initial state, which we're going to maybe first boot up the router, layer 3 device, or maybe we had a configuration change. We have to restart the process, and then it's going to have a learning state. So it hasn't determined the virtual IP address and hasn't seen a hello message yet. We want to kind of hear from the active router, see if there is one. Then we're going to listen. At this point, we know the virtual IP address, but we're neither active nor standby. We're just receiving to these hello messages, and we're trying to get a lay of the land before we make some decisions. Then speak. We're going to start sending hello messages and participate in the election of active or standby routers, and then standby or active. So standby, we're the next, or we are a candidate. We're not next. Wrong protocol. I'm sorry. So we're a candidate, become the next router. We're in standby. If we're in active, obviously we're in active mode. We're actually forwarding traffic. We've got that virtual IP and MAC address to where we'll answer to it. These hello packets are going to be sent every 3 seconds on this multicast address 224002. The standby router will become active if it does not receive a hello message from the active router after 10 seconds. You can lower these timers to speed up the failover or preemption. However, to avoid increased CPU usage and unnecessary standby state changes, do not set the hello timer below 1 second or the hold timer below 4 seconds. This is really good practice here. Most of the time, 10 seconds is going to be fine, depending on your environment though. So, for example, I've got some networks that are absolutely mission critical, and I like to isolate networks that are mission critical from ones that aren't. And so for the networks that are mission critical, I would say having a hello timer of 1 second and a hold timer of 4 seconds to have a maximum loss of 4 seconds of traffic absolutely makes sense. But for my average user, for my average Joe, that if his connection goes down for 10 seconds, it's no big deal. I'm more than happy to leave it at 10 seconds. Now, of course, everybody thinks their time is valuable. It's upsetting to go down for a few seconds. But we really don't want to have unnecessary strain on our hardware because of something like that. So usually it depends on your environment. It depends on the criticality of your network. It depends on your cost of your average employee. If your employees on average cost $10 to $15 an hour, you might not be really worried about 10 seconds. If your employees cost $100 an hour, you might be worried about every 10 seconds. So it really just depends on your environment. Know your environment, know your organization, and make decisions that make sense for you. So we can configure HSRP. These are the steps here. You can go over those if you want. I'm going to look at the commands because that's how I roll. You want to set it to version 2. I wish Cisco, a lot of these things, it's like, hey, set this to version 2. Why don't you just have it by default in version 2? Why is version 1 the default? Nobody uses HSRP version 1. You can go and have a command in there to allow them to change it back to 1, but you should have it by default on 2. Cisco, please. Every other vendor's doing this. Cisco just, some other stuff, just give me the heebie-jeebies. I'm like, come on, you can do better. So make sure you're in version 2. And then you're going to use the, and by the way, HSRP, the word is standby. Whenever you're configuring HSRP, it starts with standby. So if you don't remember, all you remember is standby, then you can type in standby and a question mark, and you can find out all the commands you need. Standby, we're going to make up a group number. Now, usually, a group number is going to match with a VLAN number. So, for instance, if I have VLAN 10, and I want to make HSRP on VLAN 10, well, I'm going to put standby 10 for my group number, my IP address, maybe it's 10.0.10. 1, for example. And so it's really, really easy to follow which groups are which VLANs, and which VLANs are what IP addresses, because all those things match, right? So I matched that 10 in the third octet as IP. I don't know if you noticed, but having all those things matched is very, very easy to troubleshoot compared to if they're just what a number was available. So yeah, HSRP group 34. Yeah, that's for VLAN 76, and you're just like totally confused. And you're like, can I draw this out? I need like a spreadsheet or something. We don't want all that. We want very, very simple configurations, straight to the point, easy to pick up and go, especially when you have employee turnover. So then we're going to, again, use the standby command. Now you'll see we're in the interface configuration mode. Just keep that in mind. So we didn't go into a standby configuration mode. We went into an interface configuration mode. Now, in the case where you'll have routers, you will probably use, and let's just say this is a big old switch right here, you'll probably use these interfaces. Now, if you're using layer 3 switches, you would not use physical interfaces. You would have these layer 3 switches, which look something like this in Cisco's drawings. I apologize for my terrible drawings, but here you go. This is the best you got. So we have these switches, and we'll have this network here. Well, now it's not a physical interface, because more than likely this is a layer 2 trunk. It could be a routed port with, you could do that. Most people aren't going to though. So instead you would have a VLAN interface that then you would be in your configuration mode here of your VLAN interface. So just keep that in mind. You can do this on layer 3 switches. For the purpose of this, we're probably going to refer to them as routers, but really any layer 3 device that supports HSRP, obviously you need to support it. But most layer 3 devices would support some type of FHRP. And then, of course, we're going to use the same group number to specify, and then a priority and a priority value. So, right, remember we have 0 to 255, 100 is the default, so we can set it higher or lower, depending on what we want. Then also, if we want to preempt, standby, the group number, and then preempt. Super simple. So you can see here, active router, priority 150, standby router, priority 100. See the configuration here, right? We went into physical interface. We set a physical IP. You'll notice this is not the first IP. This is the second IP available in that subnet. We're going to have the standby IP, the first IP, because that's what we're going to actually use for our default gateways right here. And then the other router, I assume, will be .3. We're going to set a priority of 150. We're going to set it to preempt, so we want to take back over if we go down and come back up. And then no shut, of course. Now we can do our show standby and verify that our state is active. How many state changes we had, the virtual IP address, right? Again, this is going to be the IP address we use as the default gateway. The virtual MAC address, which actually you'll see here, is group 1. These 3 numbers here in hex, let me clear it out here. The 001 here is actually for the HSRP group number. And so say you had group 200, then it would be F200, right? Makes sense. Hopefully it does. Anyway, that'll tell you the FHRP group, or really HSRP group, really easily from a MAC address. So if you see this MAC address, all this is the same up to the F, that frank, and then those 3 last characters are for the group number. Preemption is enabled, as we can see. Standby router is .3, as I guessed. Priority is 100. And of course, it expires in about just under 10 seconds. So that's when, if we stop sending hellos, it will take over as the active router. Group name is HSRP G011. And that's the default name. And we can do show standby brief. This interface, group 1, priority is 150, state is active. Active is local, the local router. If it was the other router, you'd see the other router's name here, or IP address. Standby here is the standby IP address. And the virtual IP address, again, is the IP address we're going to use for all of our clients' default gateways. And showing standby here, we'll see the active is the other router, the standby is local, our state is standby router is local, preemption is disabled, same virtual MAC address, same virtual IP address, but we're not active, we're standby. So we're not actually using it, we're not actually advertising it, but we have it there. So if we power off R1 here, this is what our debug log is going to look like. So we turn on debugging, blah, blah, blah. You'll see here, group 1 standby, active timer expired, or this was the previous active router. Then now the active router is local. We've taken over after 10 seconds. Then we see this kind of happens simultaneously. You'll see these messages are at the same millisecond here. I think actually all of them are here. So you'll see instantly this goes down, or the timer expires, active router changes, no longer active, was active, but it's no longer, standby router is unknown, and then we go into active state. Now, this happens all in a fraction of a millisecond, super, super quick, once we've figured out that, it probably is down. So R1 is reactivated and initiates a coup to become the HSRP router. So you'll see here in the debug logs, it actually says a coup from 10.2 with a priority of 150. And then it says, hey, actually we received from a higher priority router. And then eventually, after all this stuff, we're actually going to go through, active to speak, speak to standby somewhere. There it is. I was totally ignoring the blue text. Speak to standby, and we will go into standby mode, and R1 will reactivate. Now, this is something I want to take a little bit of time. A VRRP is really just an open standard for HSRP. Very, very similar, pretty much the same, other than some tiny details like verbiage. So really, it's just an open standard for HSRP. It works 99% the same. Now, GLBP is, again, a Cisco proprietary. I'm probably going to spell this wrong. Proprietary. And it provides us with load balancing. Very, very important. Now, VARP is going to be another standard that other vendors can use that is basically GLBP, but is available for other vendors. So that's it for this module. Go back, review anything you're not familiar with, any of these acronyms that you can't say 5 times fast, stuff like that. And if you have any questions, of course, send them my way. I'm happy to help. This is really old and you shouldn't be using it. Other than that, thank you for joining me in this module. We'll see you guys in the next one.